Hello guys, in this video we are going to discuss the solution of the problem add binary strings. So let us look at the problem statement. The problem statement says given two binary string s1 and s2 consisting of only zeros and 1, find the resultant string after adding the two binary string. Note, the input string may contain leading zeros but the output string should not have any leading zeros. So for instance, if s1 is this binary string and s2 is this binary string, if we add these two binary string, the resultant we will get is this, and this is what we need to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is, first what we are going to do is we are going to skip any leading zeros for string s1 and s2, and then we are going to perform the addition for string s1 and s2. So that's the whole idea behind solving this problem, folks. Now let us discuss the pseudocode of this problem. So let us say two binary string are given to us and we want to perform addition on these two binary string. So for this, what we are going to do is we are going to set I is equals to len of s1, since the addition should happen from the LSB. Similarly, j is equals to len of s2 minus 1. And then let's have end1 equals to end2 equals to 0. So the ending index. And let's also have a global variable self.carry and initial value is equals to 0. And then our answer, initially it's an empty string. So the first thing which we are going to do is we are going to skip any leading zeros. And for that reason only end1 and end2 are being used. So let us do that. So while end1 is less than len of s1 and s1 and 1 equals to 0. So this is a leading 0. In such case, all we have to do is we just have to say n1 equals to n1 plus 1. And the same thing we are going to do for string 2 as well. So while n2 is less than len of s2 and s2 and 2 equals to 0. In such case, n2 plus equals to 1. And using these statement, we will be able to skip any leading zeros. Now, once we have skipped leading zeros, now let us perform the addition operation. So for that, let us iterate while I is greater than or equals to n1 and j is greater than or equals to n2. And then let us have result equals to self.add s1i, s2j, and then let us add these two characters, and for addition let's say we have an add function with us. After adding these two characters, the result will be there in the result variable, and let us update our answer now. So if result equals to 1, then in such case answer will be equals to answer plus 1, otherwise answer will be answer plus 0. And then all we have to do is we just have to decrement our I and j counter by 1. Now after this loop ends, it might be possible that s1 string still exists. In such case, we are going to perform addition operation for the s1 string. So let us do that. While I is greater than or equals to n1, result will be equals to self.add s1i, and for the second character we are going to pass 0, and then let us update our answer. So if result, then in such case answer will be updated by 1, otherwise answer will be updated by 0. And then let us decrease our I by 1, and the same thing we are going to do for s2 string as well. So let us do it. While j is greater than or equals to n2, result equals to self.add s2j and 0, and then let us update our answer. So if result, then in such case answer will be updated by 1, otherwise answer will be updated by 0. And towards the end we have to check if carry is still 1. If carry is still 1, then in such case answer will be updated by 1. And finally, folks, the answer is there in the reverse order. So in order to return this, all we have to do is we have to reverse our answer. So for that, let us reverse the answer and send it. Now let us finally look into the add function. So let us say we want to perform addition operation. ch1 and ch2 is given to us. So for this, what we are going to do is we are going to take result equals to 0, and then we are going to check if ch1 equals to 0 and ch2 equals to 0. So the 4 combination we are going to iterate it over here. If both are 0 and carry is equals to 1, in such case result will be equals to 1. Otherwise result will be equals to 0 and carry will become equals to 0. So in this case 0 plus 0 plus 1 is equals to 1, which is there in result, and there is no carry, because of which self.carry has been set to 0. In this case 0 plus 0 plus 0 is equals to 0 and carry is equals to 0, because of which we are setting carry equals to 0. And the same thing we are going to do for elif ch1 equals to 0 and ch2 equals to 1, or ch1 equals to 1 and ch2 equals to 0. So if either of these conditions are satisfied, then in such case we are going to check our carry. So 0 plus 1 is 1, and then we are going to perform its addition with carry. So here carry is equals to 1, because of which result will be equals to 0 and carry will be equals to 1. Otherwise result will be equals to 1 and carry will remain 0 itself. And then finally elif ch1 equals to 1 and ch2 equals to 1. In such case, again let's check if carry is equals to 1. In such case result will be equals to 1, result will be equals to 0, and in both the cases carry will have to be set to 1. So self dot carry equals to 1, and towards the end we just have to return result. And in this way the addition function can be written. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. Over here we want to perform addition operation on the binary string s1 and s2. Carry is equals to 0, I and j has been set to the end of the string s1 and s2, and 1 and n2 equals to 0, and answer is an empty string. The first thing which we did is we skip any leading 0, because of which n1 and n2 has been set appropriately. Then we are iterating on the string. We are performing the addition operation and updating our answer. If there still exists string s1, then we are performing addition operation for string s2. The same goes for string s2. Towards the end we are checking carry. If carry is equals to 1, then answer has to be updated by 1, and towards the end we are reversing the string and returning it. And in the add function we are performing addition operation for 4 combination, which is 0 0 0 1 1 0 and 1 1, and towards the end we are updating our carry and result. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. I and j has been set to end of the string. Carry is equals to 0, answer equals to an empty string, and n1 and n2 equals to 0. First we have skipped any leading zeros, and then we are performing the addition operation. In the addition operation, carry and result will be updated, and in this we are checking if result equals to 1, then answer will be updated by 1, otherwise answer will be updated by 0. If there exists string s1 which has not been covered so far, then we are covering that part and we are updating our answer. The same thing goes for string s2 as well. Towards the end we are checking if there exists a carry, then answer has to be updated by 1. Towards the end we are reversing our string and returning it. And in the addition function we are again performing addition operation for the 4 combination, which is 0 0 0 1 1 0 and 1 1, and we are updating our result and carry. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.